Hello guys, this is Fazan, and in this video I'll be giving you the curriculum overview, assessment structure and examiners expectation of Cambridge IGCSE 0625. In this video I'd be explaining you the philosophy of this curriculum, what are the key areas, what are the key study areas or the topics or the units of the curriculum, what's the syllabus of the curriculum, how your assessment is structured, how you would be assessed, what is the marking scheme, what are the assessment objectives, that how the questions are posed to you and what the examiner is trying to assess in you, and what are the examiner's expectations. So moving forward, what is Cambridge IGCSE Physics? It's an internationally recognized qualification which is given to you by Cambridge University, and you need to remember the syllabus code, which is 0625, because this syllabus code is used to access your mark scheme, examiner report and correct past papers. So what is this curriculum emphasizes on acquiring scientific knowledge and understanding. It not only wants you to know laws, like most of the curriculums focus on the memory of the person. Okay, they focus that how much a student is able to remember, but this curriculum focuses on the scientific understanding. It focuses that are you able to understand the things. Say for example, if you know the law F is equal to ma, knowing the law, memorizing that force is equal to mass times acceleration, it's memory. But understanding means that would you be able to apply this law in problems if you have. Okay, the second thing it focuses is that developing the experiments and practical skills. Okay, are you able, if you would be given a laboratory or if you be given a physics lab, if you are in an experimental setup, are you able to develop experiments, are you able to practice experiments? Okay, whatever experiments you're studying in the theory, like how do we measure the charge of an electron or something like that, so would you be able to do? Are you able to use scientific data and evidence to solve problems? For example, for a numerical, you will be given some data. You have a car. This car is being given with some speed, say for example 5 meters per second. Okay, and you would be given some other data. You would be given some situations. Would you be able to get the desired result? Okay, that's what it wants. Would you be able to communicate effectively using scientific terminology? Okay, would you be able to define things with the precise scientific terminology or not? Okay, and this develops an interest in scientific inquiry. This curriculum is focused in such a way that you have a good interest in scientific inquiry of the things, that how a physicist basically see to the things. It develops that intuition, it develops that understanding, it develops that thought process that you need to have in order to understand and think physics. Now, coming to the course structure, how is course structured? The course is structured over 6 main units, chapters or modules you can say. The module 1 covers the motion, force and energy. It will deal with the motion, how is the motion happening, why is the motion happening, what are the energy change, what are the momentum change. Okay, how the pressure change, how one quantity in the mechanics, if one quantity in mechanics will change, how the other quantity will depend on it. So this all will be covered in the motion, forces and energy. Then in module 2, you would be dealing with the thermal physics, you would be dealing with the microscopic levels of physics, you will be studying about heat, you will be studying about the transfer of heat, you will be studying about the heat capacities, you will be studying about the change of state, okay, how liquid gets converted to the solid and solid gets converted to the gas, or how solid gets converted to the liquid and liquid to the gas, how the exchange of these states happens, and what is the exchange of heat, how heat plays the role there. Then after that you would be coming to waves. What are waves? You would be talking about the energy transfer of energy without the actual transfer of matter. So you would be seeing that how sound propagates, how light propagates, how reflection of waves happen, how diffraction happens, okay. So this all is in the chapter or in the module of waves. Then will come the electricity and the magnetism, where you will deal with the particles having charge, you will deal with the electrons being at rest, or charge being at rest, charge being in motion, okay. The motion charge having the velocity and acceleration, okay, with the velocity producing the magnetic field around it, and how magnetism is linked with electricity, okay, how with the help of magnetic field you can produce electricity, the changing flux and all. So that would be studied in electricity and magnetism part, okay. Then the fifth module is going to be the nuclear physics, and in the nuclear physics you will be studying about the atom, the structure of the atom, the subatomic particles, okay, how are the different energy levels in an atom, how electrons go in and out of an atom, how electrons move inside the atom, what rays, the alpha rays, the gamma rays, what is the half-life of a reaction, what are the applications of these nuclear reactions. You'll be studying about nuclear fission, nuclear fusion, how the nuclear bomb is made, how sun makes the energy, okay. Then the final module is the space physics. The space physics you're going to deal, it's going to connect your physical understanding to the understanding of the universe. You're going to learn about the solar systems, you're going to learn about the stars and galaxies, that how stars are formed, what role stars play, how stars are creating the gravitational field and making planets orbit them, okay. You'll be life cycle of the stars, the redshift you'll be talking about, and how universe is expanding. So if you're going to see the course is structured in such a way that you get a holistic understanding of different kind of phenomena in physics, and you would be able to understand the world around you through the lens of physics, okay. So this curriculum structures serves as the introduction to the different dimensions of the physics, different branches of the physics, okay. So understanding these topics is going to increase the understanding of universe around you, that how the universe functions. But if you can see, we have two kind of curriculums here. We have core and extended curriculums. There are total grades going from A to G, okay. So there are two ways you can take this curriculum. The first way is to take the core curriculum. In core curriculum, your scores can go from G to C. So the top score is going to be C, the worst score is going to be G. You will be having the core content only. You will practice the fundamental type of questions. It's not going to be advanced problem solving. So the purpose of this course is to achieve the fundamental understanding of the physics, to understand the basic dimensions of the physics, okay. And your assessments would be based on only the content that's in the core. Now the extended curriculum includes whole of the core plus some supplement content. So the purpose for the extended curriculum is to develop deeper understanding and advanced problem solving. So the students who deeply want to understand the concepts of physics take this extended curriculum, and the assessment of this curriculum is also based on the contents that's in the core and the supplementary content that would be given to you. What you need to understand is that in extended curriculum, your grades the maximum grade you can score is A. There is no way in the core curriculum that you can score A grade or you can score a B grade. Okay. The only way to score A and B grades, the grades above C, is to go with the extended curriculum. Okay. So these are the different ways that you can take for this curriculum. Now, how would you be assessed after finishing the course? How would Cambridge assess you? For core pathway, there are going to be 3 papers, and for extended guys, there are also going to be 3 papers. So every candidate would be assessed in 3 ways. You would be given an objective question paper, multiple choice question paper. You will be given a theory paper and a practical. So multiple question. So for core students, they are going to take paper 1, paper 3, paper 5 or paper 6, any of them. Paper 1 will cover the multiple choice questions. Paper 2 will cover the theory, and the syllabus will be from core only, okay? The core part of it. And practical skills are going to be tested in paper 5 or paper 6 based whatever you choose. So the awards are going to be graded from C to G. The maximum you can go to C, the minimum is G. Okay. Now for that we have extended path. The extended path has also 3 papers. The paper 2, paper 4, paper 5 or paper 6. Any of them. Paper 2 and paper 4, the questions come from the extended part of it, okay? Which we said the core including the other syllabus. So the theory will also come from the extended syllabus. The paper 5 or paper 6 is almost same for the both core and the extended ones, okay? So Cambridge tries to assess you in different ways, okay? It tries to assess your deep understanding and application and the practical, that how much good you are with the experimentation. It tries to assess you in different ways. So that's why it has 3 different formats in which it's assessing you. Now, what's the weightage of each paper? What's the weightage of each paper? So 50% of your marks will come from the theory paper, 20% will come from the practical assessment, and 30% from the multiple choice, okay? The objective of the theory paper is that it checks your understanding and the reasoning, physics reasoning, okay? The objective of multiple choice is that it checks that how well you are able to do the problem solving, how well you are able to do the questions and all, okay? And the practical assessment checks you that how good you are with experimenting things, okay? So the theory is the backbone. It dives deep into understanding the clear scientific explanations, the precise definitions. The multiple choice test is knowledge. It just tests that how good you are able to recall a formula, and what's your application speed. And the practical skills are going to test that are you able to investigate intense and scientific problem. Are you going to how would you analyze it, okay? And how would you interpret the real data there? So the focus is that you should be able to get concepts, the deep concepts, okay? You should be able to explain them clearly, and you should have good practice, okay? So this should be the focus. Now, if you're going to understand each paper, how each paper looks like. Paper 1 and paper 2, okay? Paper 1 is for core and paper 2 is for extended. It's going to be a multiple choice paper. You will be given 40 minutes, you will have 40 questions, and 40 marks would be given, okay? So objective is to test your knowledge. Are you able to analyze the diagrams? Are you able to put the concepts into unfamiliar conditions and contexts? You carefully need to read the questions and manage your time well in paper 1 and paper 2. Talking about paper 3 and paper 4, it is a theory paper, core and extended. So paper 2 is going for the core, paper 4 is going for the extended, okay? The duration is going to be 1 hour 15 minutes. It comes it gives you 50% of the marks and total of 80 marks. So you should be good with answering the phenomena, answering the questions. Your answer should be short and you should have structured way of answering the questions. You should demonstrate that how well you understand that concept and how deeply you understand the concept. You should explain the physics reasoning behind the concepts, okay? And precision in language is also very important. You need to use the physics terminology for the things to explain the things, okay? Then the paper 5 is a practical test. You would be given an experiment and you need to perform that experiment. It checks that how well you are able with experimenting things. You are able to analyze data, take observations, and get the conclusions from the experiments. Then comes the paper 6. It's an alternative to practical. You don't need to actually perform the practical, but you need to write about the practical, what apparatus to be used, and how the practical should be done. So, out of paper 5 and paper 6, you're taking one paper based on your school and whichever you choose. Now, what are the assessment objectives? Whenever they're giving you a question, what is the examiner actually assessing in you? Okay, examiner is assessing your knowledge. That are you having the knowledge of this thing? Are you having the clear understanding of this thing? He's assessing that are you able to handle data and are you able to solve problems with that data? Okay, for example, in numerical you have a certain kind of data and are you able to get a desired result from it? And in case of the practicals, you should be good with the experimenting things, okay? So it's either checking that how good you are in the experimentation. So knowledge and understanding, do you know the thing and how deeply you know the thing? It checks, this is the first thing that they're going to check. Second thing, AO2, is going that if you be given the data, would you be able to interpret that data and get from that data using the formulas, using the laws, get the desired result? Okay, are you able to analyze the tables? Are you able to perform calculations? Okay, and everything. Then they also are checking that how good you are with the experimenting. Like, are you able to experiment? Are you able to say, for example, you need to find a charge of an electron. Would you be able to find it experimentally if this experiment is in the syllabus? Okay, so what are the common mistakes that students make? The common mistakes that students make is the weak response. Like, their explanation is not clear. Okay, they're explaining the plain basic language in vague terms, not using the scientific terminology, not using the precise scientific language. So, for example, we have a question: why pressure increases? Student answers, because force increases. Okay, what's the problem with this answer? This answer is incomplete. This lacks scientific terms. There's no reference area. This limited explanation. But what if we answer: pressure increases when force applied is increased and area over the force over which the force acts decreases, because pressure is the force per unit area acting at right angles. So this is a strong answer. This has complete and accurate information. It links force with the area, uses terminology, and has a clear scientific reasoning. Okay, so examiner values your scientific accuracy and competence, that how well you are scientifically, okay, how good language you are used. Clear explanation in your own words. You should be able to explain the phenomenon very clearly in your own words. You should use correct scientific vocabulary. You should use correct scientific terms. Understanding the relationship between reasons, okay, that if the cause and effect, if A is happening, how B will change. If quantity A will change, how B will change. And you should be having that ability that you give a context to your ideas. Okay. We're trying to understand what examiner is looking at. Okay, what examiner is going to look at. Examiners will reward your clarity, your accuracy, and well communication. Be as much clear to your answer, straight to the point, precise with the scientific definitions. This is what examiner is expecting from you. He expects that your explanations would be complete. Okay, you would be able to use precise scientific language. You would be able to show the process of calculations. Okay, and one more thing: if your method of answering, is right, If your physics reasoning is right, the final answer is wrong, the examiner is still going to reward you the marks because you understand the reasoning. And that's the main thing this curriculum focuses on, that how well you are able to reason with the physics. Now, there's some command words that you need to understand. Say for example, the question is like in the form of state. The question is like state the SI unit of force. The question is like that. This you can answer in one word. Answer precisely, straight to the point. Say for example, I said Newton. If you say you describe, okay, you need to explain what happens. Okay, so you need to focus on the behavior. Say for example, the question is describe what happens to the speed of an object during free fall. Okay, so you need to describe what's happening there. So what you will describe, you will say speed increases. Say for example, the examiner wants to check your observatory behavior, that how good observant you are. Okay, so if he says that explains, so give a scientific reason, explain why and how. For example, explain why metals are good conductors of electricity. Reason using scientific principles and correct terminology. How we have answered it? Metals contain free electrons which move through the material and carry electric charge. So we give the clear scientific reasoning. Okay, metals have electrons and electrons move. Because electrons move, the electrons have charge. Okay, and if electrons can move, electrons can have charge, metals can conduct electricity. If you have to calculate, you need to use the data to find the answer. You need to show full working. Say for example, you got to calculate, you're being given force 6 Newton and 10 Newton, they're acting in the same direction. You write the equation first, you substitute value there, okay, then you carry out the calculations like we have it here. Then we have suggest. Suggest means that the question can have more than one correct answer and you need to suggest an answer to it. Okay, so for example, so scientific reasoning must be applied. Okay, so the question is suggest one way of reducing the resistance in a wire, and we answer it like increase the cross-sectional area of the wire. When we increase the cross-section of the wire, resistance increases, but by decreasing the length we can also decrease the resistance of the wire. Okay, so there are other ways of reducing the resistance in a wire, so you need to specify one among them. How you can prepare for this with this curriculum and how you can prepare for this exams of this curriculum. Okay, once you start, you must know your knowledge, know the syllabus. You must know what's included and what's not included, and specifically and strictly follow your syllabus. You must know your syllabus like the back of your hand. Okay, then you need to build understanding or the concept. You need to understand it, like really not memorize it, but understand the concept. So for example, if there are Newton's laws, the laws of thermodynamics, you need to understand what it means actually, not the memorize the formula. Okay, and then you need to apply that understanding to the different contexts. Okay, you need to practice previous year paper under timed conditions because you have time limitations in the exam. You just have fixed time, so you need to see that how you are able to solve those questions in that fixed time. And the best way to do it is that you need to practice previous year papers. Okay, study the mark scheme, that how many marks belong to what part and how the marks distribution is working out there. Okay, and do the experiments in the laboratories, develop the practical skills because it consists around 20% of your total thing. So I believe we covered the curriculum philosophy. You're clear with what is the context, like what is the syllabus of it. You're clear with the assessment structure. You're clear with the assessment objectives, examiner expectations, and preparation strategies. Okay, Cambridge builds scientists more than knowledge bases. Okay, it more focuses on the intuitive explanations. More than this, you understand and you memorize the thing. Okay, so this was it. This was it for the video. Thank you very much.